Okay, let's take a look at some information about the materials that wood framing is done from. And we're going to focus on Doug fir larch because that's what grows in our area. And the focus of this is how do we know that the wood is going to be strong enough or our design is going to be strong enough using a certain type and grade of wood. So let's see what we have to learn about then. So first we have to learn about design values. How do we know what's strong enough, what's not strong enough, what fails, what doesn't fail? We find about that in our design values. And then our tables are organized so that we can get to our answers. And we're going to find that we need to know sizes, species, and grades. And then using our charts is also important. Let me go to the slideshow view. It's a little bit cleaner for us. And so we have to learn how to read the charts, check a number, and find max loads. So lumber design values, they're the maximum safe applied stress. And there's various loading directions. So if I load it sideways, it does one thing. If I try to shear it, that's like just slicing it in two. That does another thing. Compression is another. So there's numbers for all those. And that number that's important is called stress. And it's the load divided by the area that load is spread out over. Okay, so as an example, if I had 100 pounds spread out over 8 inches, 2 by 8, that would be 12.5 pounds per square inch. That would be a stress. Okay, and it's not a real thing. It's just a way of talking about stuff. But we found that materials generally tend to, a certain material will fail when a certain stress is encountered. So that's important for us. So there's certain ones. There's extreme fiber stress in bending. If you bend the wood like you see here, it's supported on each end and there's something pressing near the middle. That tends to bend it. And there's a stress developed at the outside fibers of that wood. That's an important one for us. So that's common like when a rafter sits between two studs, that should say studs, top plates, and headers. Okay, so another one is horizontal shear. That's when a load is near a fixed edge. That tries to shear it straight off, shear it off. And compression is when you're squeezing something together. So a big load trying to squeeze it together. So different species and different sizes and different grades can all handle a different amount of stress. So our strength tables are organized by that. Size, species, and grade. And the whole goal is so the designer can look it up to see if the lumber strength will be more than enough to hold the load. So we have to know about lumber. So we call out nominal sizes, but when we do our computations, we know that they're really a little smaller. So a 2x4 is really 1.5 by 3.5. Okay, so we have to know the size. And we're going to mostly deal with 2x4s. A 2x6 is similar enough so that if it worked for a 2x4, it would most likely work for a 2x6. Okay? And then we have to know the species. And as I mentioned, Doug fir larch grows in our area, the whole Pacific Northwest from Canada down through the Central Valley of California. And so Doug fir larch is important for us, and that's what we'll use mostly. And then the grade is from select structural down to stud. and they all are used in different ways for different parts of a building. For us, remember the select structural is for joists and headers and rafters, and the studs are for studs. Okay, so that's what we'll deal with most. So this is what a table looks like. So we have to read it. So the first thing we do is we find our size, our species, and our grade, say stud. And we know the answer is going to be along the line, the row of stud. And then we have to find the particular stress that we're interested in. So if I wanted compression parallel to the grain, I would run down that column until I got to the row that I was interested in, and that would be my answer. Okay, so let's take an example. If we're going to check a lumber choice to see if we've chosen an adequate grade and size of lumber, okay, so the first thing we have to do is find out what the designer is interested in. So here, extreme fiber stress in bending. Okay, so we're going to look up the stud then and say, okay, that can take 770. That's my limit. And then the designer has said, I'm going to develop or see at the most 685. Is that okay? Well, 685 is less than the limit, so it's okay. Okay, it will see less than the maximum that it can handle. 770 is bigger than 685. The design can be accepted. So that's one thing we do. Another one is we know what the design is and we want to see what the maximum load is that it can hold. So let's take, as an example, a 2x4 in compression. How much weight can that hold? Well, I look for a 2x4 stud in compression, 895. And then I know that the area, okay, some force spread out over an area will give me 895 pounds per square inch. So the area of a 2x4 is 1.5 by 3.5. That's 5.25 square inches. So the load is stress pounds per square inch times the area square inch. That 2x4 can handle almost 4,700 pounds in compression. Seems like a pretty good load. So that's how we use these charts.